Hello friends, welcome to my channel. Let's have a look at problem 953, verifying an alien dictionary. This is a daily challenge problem. In this video, we're going to explain a solution based on converting and sorting. First, I'll read through the problem statement to digest the requirement, and then we walk through the details of the method, and finally we share the code. First, let's look at the statement. In the alien language, surprisingly, they also use English lowercase letters, but possibly in a different order. So the order of the alphabet is some permutation of lowercase letters. So given a sequence of words written in the alien language and the order of the alphabet, return true if and only if the given words are sorted lexicographically in this alien language. So this is the main statement. So here are three examples. So in example 1, so this is the order. For example, H is in front of L, in front of A, right? So in this case, we return true because H is in front of L. So in example 2, so the output is false. So you can see the explanation. And finally, the example 3 is also returning false. So before we look at the analysis, let's look at the constraints. So first, the words has a length bounded above by 100, and each word has a length bounded above by 20. So the order actually, if we regard it as a set, it contains 26 lowercase English letters, but in certain order. All characters in verse I and order are English lowercase letters. So with that said, we are ready to do the analysis. So here the idea actually is very simple. So we want to make a translation. We can use this translation word in coding or in mathematics. We can call it one-one correspondence or mapping. So the idea is that we could map the characters in this order string to A, B, C up to Z. For example, order 0, the first character will correspond to A, and the last character is corresponding to Z. So this map relation maps each word to the corresponding word. So you can understand before translation it's an alien word. After translation it's an ordinary word. So we just need to check if the transformed words are in sorted order, in natural order, right? So here are two walkthroughs for example 1 and example 2. So from the order given in example 1, so we can map this H to A, L to B, and A to C, and so on and so forth. So this gives us a one-one correspondence because the 26 characters are unique. And then the words list is transformed to a new word like AJBBO corresponding to the first word, and this one corresponding to the second word. And that the original alien words list is in sorted order is equivalent to that the new words is in lexicographically sorted order in the natural way. So for this example it is, so we return true. So similarly from the second example, from the order, so we map W to A and we map Z to Z still. So the new words after transformation is given like this. So this new words list is not in sorted order, in natural order, right? Because if we examine A, B, C, they're the same. However, E is in front of D, so this is not right. So the correct sorting order should be like this. So therefore, for example 2, so we return false. So with that done, so actually we explained the method or the treatment. So next we are ready to write the code. So once we digest the idea, so writing the code is just several lines, right? So let's first do the mapping, right? So we can write D. So we can use a dictionary comprehension. So I'm going to transform the character as current one according to their index. So we know that the lowercase English letter A has an odd number 97, so we are going to do this. plus I. So where I is the index of the character in the order list, right? So this way we establish the before and after relation, right? In other words, which one comes first in the alien dictionary. So this is for I, the character in enumerate order. So this way we established a map relation. So next we want to transform the original words list to a new one. So let's do this transformation. Words transformed. I'm going to words T. T means transformed. So here we are using we're going to use double comprehension. So first I'm going to use join method. So we are going to transform each word to a not ordinary word. In our words, let's see. So D character, right? So for character in item. So then for item in words, right? So there's a double comprehension. So this way, so we for each atom in the original word list, we transform it using the map, and then we just need to check if the transformed word, that is the word T, is in sorted order or not. So this is actually very easy now, right? So we just need to check if sorted words T. So this sort we didn't provide any specified key because we just use the natural lexical order sorting. Then we just check if it equals the word T itself, words. So if so, it's in sorted order. Otherwise, it's not. So overall, there's 3 lines of code. So for sure, you can further simplify that, but that's not the point. The main point is the mapping relation and the translation. So with that said, we are ready to do a test. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes all the test cases. So here, actually, we do this without much thought on analysis. Time complexity is due to this size determined by the 3 constraints. So with that said, I guess that's about it for this specific problem. So this is actually an easy problem marked in Leetcode, but it's interesting to further digest and think about sorting or other ways to do it directly. So with that said, I guess that's about it for this video. So you are welcome to check out other videos on coding problems and algorithm analysis in my channel. Thank you.